Okay, let's make a circle. Some of you are asking on the Facebook DM about how you generate a circle. It's a basic technique from uh, GLSL. It's basically you grab the UV of the screen. We use vertex attribute. There are a lot of attribute that we can use here, but this is a local position for 3D objects and local normal and local tangent, and also vertex color of 3D object. We can use all of this to create shaders, but right now we only concern about the UV. Uh, and we want to do this in the vertex stage, not uh, I mean we want to do this in the fragment stage, not in the vertex stage. Vertex means if you know 3D software or 3D object, we know that something 3D is made up by a lot of vertices, right? And each and every vertices are connected to create an edges, right? And this all of these edges, when they are connected, and we want to define a shape and apply a texture on it, we create a face, right? So faces are created from a bunch of edges, and edges created from bunch of vertices, right? So in this context, it's just a 2D, but it also uh, still has a coordinate to play with. Just imagine like this is a plane where there is a vertex here, a vertex here, vertex here, and vertex here, right? It creates an edges around the corner, and then it creates a face on top of it, like it's plane. So we can visualize this. What is UV essentially? So the UV is how computer communicate with us, on showing us how their coordinate system in any surface. So in this case, the surface is the camera, the screen, the screen camera. So the screen of the phone, I mean. So this is what UV looks like in 2D. What is this gradient? So this gradient represents a coordinate of x and y. As we know, there is an x axis here and y is right here. But in Spark AR, I mean in Metaspark, the origin starts from the top left corner. So the 0, 0 coordinate is right here, not like conventional coordinate that we maybe learn uh, from school, where it's often represent right here. We can see many different origin. It really doesn't matter. It's just what the software want to set as the origin. The origin can be here, the origin can be here. It's up to them. In this case, Spark AR has the origin of this top left corner. So what is 1.1? 1,1. 1,1 is this, represented by this yellow color. So the greener it is, it means that it's going from 0 to 1 in the y, and the redder it is means it's going in the x-axis from 0 to 1. And when we combine red and green in the uh, let's just look at here. We set a value, right, with factor 4. This is red, green, and blue, and alpha. It's interchangeable, the X, Y, Z, and W. So we plug it here and nothing shows up. Why? Because first, there is no alpha. So we set an alpha. So the alpha is 1. Alpha means opacity. So now we see something but black. Why? Because there is no value in the red, green, and blue, right? If the red column here, we set it to 1, it changed to red, right? If we change the green to 1, it becomes, of course, green. What if red and green we set to 1? It becomes yellow. That is why we see yellow right here and red right here and green here, right? So this area, this point means it's this, right? This become all over, right? And sorry, and this right here, this point right here, represented by this, right? So that's how it works. And let's go back on making a circle. When we want to create a circle, we need to know where the origins, or where we want to define the middle of the circle and set a radius from there, right? So if we want to create a circle from here, the origin is right here, and we can set a radius around it, right? But that's not a circle. That's a quarter of circle because it's right there. We want to make the circle in the center, right? So how we do that? First, we do some simple mathematics. How? We just subtract it by how much? By 0.5. Why? Because we want to offset, we want to move this origin right here to to here, right here. Now it's right here. Also, when when we set this to 0.5, it means it's 0.5 on both axes, right? We can just set it 0.5 to for the y or for the x, depending on how we set this value. But just to simplify it, we just set to this single value and it applies to both of them. But for clarity's sakes, let's just represent it in the proper way of 0.5 on x and 0.5 on the y. We subtract from this value, from this coordinate, to make it move to this coordinate now. Now, we have a problem. Why? Because now it's the range of the range of this field is starting from 0 to 0.5, and we want to make the range into 0.1 range, 0 to 1 range. But of course, when we want to set it from 0 to 1 range, then it means when this point goes right through the corner right here, it means it from 0 to -1, right? We can do that by multiplying it by 2. So we now have the origin from the center, and the range is normalized to 0 to 1, right? To 1 range, right? But there is the minus value here, but represented as black, because yeah, that's how we see when we set it to below 1, we don't see any difference in here, but the computer knows what's the value. That's why it's important sometimes uh, to make sure that when something is black, is it really black or there is a value. That's why sometimes we use a clamp uh, to make sure everything below 1, even we can see it, it just set it to 0 or something, right? And now let's go back to this one. Right, so now we have a origin in the center. Like I said previously, we want to create a circle from this point into the edges of this screen, right? We want to set a radius to define the circle. Excuse me. So to do that, we can simply use distance. Why? Because we want to know the distance, right? We want to we want to set a radius. How to set a radius? We have to know the distance from point A to point B, right? So we plug this in directly, and we have the field, the distance field of this UV. What these colors tell us, right? This color, it's just a single value. It's not RGBA. It's just an alpha. It's just a single value represented as a shader generic and shader generic data type. And this we can use it to set a threshold of the circle by using step, right? And this step, if I plug this in, we can't see anything. Why? Because this step is a way, step function is a way to tell the computer where something lies, right? Let's change the value to 1. Why? I set it to 1 and it creates a circle, an oval. This means the edge is 1, means as we can see in this oh, right, this from 0 to 1, right? From 0 to 1, from 0 to -1, 0 to -1. This tells the computer we want to make the everything above 1, everything above 1, make it white, right? And everything below 1, make it 0. That's simply how it works, right? Why it's often called sign distance field. It's a sign distance field. Sign means we attach a sign of area. Everything below 1, we sign it as an inside, and we sign the above 1 as the outside, right? And we can invert this, of course, simply by subtracting this to 1, and voila, the the one area is now in the middle and the outside is black, right? But this is a single value, it's not a color yet. When we want to use this as a color, we need something to represent it, of course. This is just a mask, simple mask. So we can use it as the alpha of the first color and the second color. Let's change it to white. Everything outside of uh, 1 will be black because we do this inversion. So let's just forget it first. So this tells us everything outside of this edge, set it to 1, and everything below will be set to 0. This is how you create a circle, but not a circle yet. Why? Because this is a circle only if the object is a rectangular, if it's a square, right? Like, let's do this right here. Now it's a perfect circle. But when we apply it to a full screen, this texture will be stretched, right? That's why when we apply it to this, when we apply it to, oh my god, when we apply this to the full screen, it stretches in the y-axis. How we fix that? We can get the aspect ratio from the device. So we grab the screen size, unpack it, set it to factor 2 because there is only x and y, and we want to divide the x-axis, the longest one, by the smaller one. And let's analyze this first, so we know the thought process of this this process right here. So if this texture is stretched in the vertical axis, like the y-axis, we want to squeeze it down, right? To squeeze it down from this point to this point, and from this point to this point. We need to scale it, right? Only on the y. So we need to apply this aspect ratio only to the y. The simplest way is using Swizzle because it's a valuable tool to help us set a simple factor. We don't want to change the x, right? We want to keep the x as it is because there is no problem with the x, only with the y. So let's set the x is to 1 and the y-axis is from this result, right? And after that we multiply this with this one, and now we have a perfect circle on a full screen, but it's mapped to only match this. The maximum is from the x because that's often what we want, right? We don't want to see like this, right? It's how people know it's a circle where when everything is cropped off, right? So it's oftentimes this is what you want if you want to create a circle. So with this understanding, we can see that first we offset the origin to be 0.0 in the center, right? So what if we want to change this? So the circle starts from this, from here. We can just change this, or I personally prefer a way of just adding another math node, right? Oops, not here. Let's factor 2, right? We already are satisfied when the origin is center. We just want an offset, right? We can set it right here. Positive goes to right, negative goes to left, and also this positive goes to down and negative goes to up. It's a little bit counterintuitive for the Y. It's simply because Spark set the origin somehow on the top left corner, so the Y will always be inverted. It's just how it is. So that's how you offset it. So this is how you create a circle. And what if, right? What if we want to have a lot of circle, right? Like in the effect that I post earlier on the Facebook page, I have a lot of circle. How you created that? So it's simply by, look, we generate this circle from this one coordinate. How to make more circles? We make more coordinates. But how you make more coordinates? Of course, the simplest way is by duplicating it and put it on the side, right? In normal people, I mean, in general terms, it's just a styling. It's styling, okay? It's styling. So this is how to tile a texture or a UV or anything you want in image processing. This is the texture coordinate. We want to how to make it becomes more than one. We multiply it, of course. But look what we get when we multiply this. It just creates a bunch of yellow. And this is because we just increase the range from zero point 0.0 to 4, right? Now it's from zero point 0.0 to 4. What we want is to repeat from 0 to 1 and 0 to 1 again and 0 to 1 again and 0 to 1 again. And guess what? We can do that by using the Majestic Modulo. Plug this in. Boom! Oh my good gracious. Look at this. Why it tiles like this? We multiply it by 4. Why it generates 16 of them? Of course. Why? Because this 4 means it's a factor 2. It's 4 on the x and 4 on the y, right? If you just want the x, just set the y to 1 and you only tile it on the x-axis. If you want to set the tiling only on the x, just set the x. If you want to tile it on the horizontal, the vertical, just set the x to 1 and horizontal to 4, right? That's how tiling works. This UV can be used to create more circles now. So let's try to plug this in and put this here. Whoa, we have 16 circle. Wow, amazing, right? Astounding. Wow, we can set all of them uniformly. So that's how you create more circles. Now, this technique can also be used to generate any other shapes or any other effects. We can use it to tile a texture. Let me show you a little bit more. Let's get a camera texture and sample it. Right? This is how to sample, and then it asks for the UV. If we plug this right here, we don't see anything. Why is that? Right? Why? It's because, like I told you earlier, the computer works by coordinates, right? Let's go back to this one. Excuse me. The computer use coordinates to show us any given pixel of something, in this case a texture, right? The texture, camera texture is this awesome park, right? It has origin from 0.0 right here and 1 right here. If we just plug this right in, it shows an absurd color. Why is that? It's simply because we sample this exact point in the coordinate 0 0. What is 0 0? This is this pixel, right? And apply to everywhere, right? To the full screen. That's not what we want. We want to tell the computer, dude, we want this from here to here and then to here, right? It's an area. We want an area. We want a field, not a single point. That's why we use this. Yeah, this UV tells the computer to sample each and every pixel on this screen, right? And apply it to the full screen. That's how UV works. And let's use the UV after we tile it. We can do that. Yep. And now we have 16 camera texture part, right? Nih, that's how you tile a texture. Um, the the thought process behind why it's tiling is, the more you add something, the smaller it is, because you need you have the same amount of space in this screen, but you want to add more, so it's automatically just go smaller, right, to fit every tile, right? So this multiply means actually without this modulo, let's see what happens, right? It's just gonna clamp, right? It's gonna reproduce this 0 to 1 and everything goes to this weird pixel repetition, right? What is it? I often see this uh, in published effects. This is because the last pixel that we sample is like this one, right? These edges, right? And the computer doesn't really have any more texture above that range, right? So the computer represent those missing values by simply sampling the last pixel and apply it to everywhere, vertically or horizontally. That's why we have these clamped artifacts, right? But if we set modulo, we tell the computer, if you go above this value, you go back and start all over, right? From zero again. That's why we have a tiling texture. So this multiply also you can interpret it like a zooming effect, right? What do you mean by zooming effect? So let me show you. Okay, we go off tangents, but it's okay. If you want to keep listening, good. If you just want to make a circle, you can stop. So um, zooming something is simply make the texture smaller. I mean, let's just I just show you, man. Let's just plug this in and set this back to 1, right? When we want to zoom in, right? We want to zoom in. It means make the texture look smaller by multiplying it with smaller values. Like look, look. Why? Why this happens? It zoom in, but it goes to the top left corner. Why? Guess what? Because the origin is right there. That's why we zooming in to that origin. That's how zooming works. That's how the thought process works behind this zooming effect. So how then? How to zoom to not the corner, but I want to zoom in the middle, right? Of course, like we did earlier, we subtract it and then multiply it and then zooming it in, right? Let's just do that. We zoom in first, right? Just so to be clear, right? Now it's only sampling this area, right? This area, right? But we want to move it from this to go here, right? What we do? What we do earlier? Just do a simple additive or subtractive math to do the offset. Now it goes to the right where this is clamped. If you don't want to see this, just use modulo and it's going to repeat after it sees these edges. It will sample from right again and so on and so on, right? So what we want is to zoom in the middle, right? This is what you get. But this one, you have to accommodate the zooming in by the subtraction, that offset that we do right here, right? So how we do that? Of course, you can just do another math. It goes back to where we were, right? So now we can just okay, to be more clear, we can now zoom in. Oops, oops. Right, we can now zoom in the middle, but that's not how we want it to look, right? So how to do that? To keep it consistent, right? We want to set the offset to change gradually while we offset it, right? So what we are going to do is simply, first you need to define the origin. Like this is the origin, right? This is the origin. And okay, let's just forget this. We can just, if you want to simply scale a texture or something, you actually don't need this. You don't need this. You can just use the texture transform, right? Texture transform, it's just the simplest way to transform a texture. But what it does under the hood is, it's just like what we did earlier, right? It's just offsetting something and multiplying the value, and also rotating something is just by doing a rotation matrix or manually using cosine sine. This is like the translation is just like this one right here, and the scaling one is like doing this multiplication by defaulting the origin uh, to any given value. But in this case, the origin where we want to scale it is from 0.5 to 0.5. This one is this one, right? we want to make sure it zooms in when we scale it up, right? It zooms in to the middle, right? Yep, that's it. That's definitely it. So yeah, thank you. I hope this tutorial is kind of helpful. If you want to create a circle or to sample texture, you now know how the UV works, how this sampling works, and how computer communicate with us using this texture coordinate, right? I hope this helps you in your AR creation journey. Thank you.